now we will discuss about the excitation energy of the energy levels. You have heard the so many energy levels in the hydrogen atom or some other kind of atoms also. And these energy levels are denoted by K, L, M, N, O, P, like this one. And the first energy, the ground energy state, first energy state, second energy state, third energy state, etc. And this is given by according to the Bohr model. So we know that the whatever the energy is possessed by the electron in its orbit or in its energy level, that is the excitation energy. The energy possessed by an electron in its energy level is called excitation energy of the energy level. Here it should be very clear to all of you that this is not the excitation energy, first excitation energy, second excitation energy, third excitation energy. This is not so. But this is the energy that is possessed by the electron in its energy level. So that is different from this one. The energy of electron in nth energy level En equal to minus 13.6 Z square upon N square electron volt. This is the energy. So now where Z equal to atomic number and principal quantum number, and this n equal to 1, 2, 3, 4, 5 and so on. So this is the natural number. The minus sign indicates that the electron is bound to the nucleus in the energy level. So now this first energy level with excitation energy. Now this is given by E1 minus 13.6 Z square electron volt. So this is now first energy level. So we are having this n equal to 1. Then this is not so much. Now second energy level with excitation energy. Here this n is equal to 2. So this E2 equal to minus. Now this is now 3, 4, 4, this is now 3.4 Z square electron volt. This is not so much. Similarly, third, energy level with excitation energy. This n equal to 3. So now this E3 is equal to minus. This is now 1.51 Z square electron volt. Right. So similarly for n equal to 4, n equal to 5, n equal to 6, we can have the energy levels. Similarly, for fourth, fifth, etc. energy levels with their excitation energy. Now we can have this E4 equal to minus. This is now 13, now 4, so this is now your 16. So 0.85 Z square electron volt. And now if we have this E5, then this E5 is equal to minus. This is now your 25. So this is now your 0. Minus 0.25. So this will be your 5 and this 11, 4, 4 Z square electron volt. And so on. So we can find the excitation energy of different energy levels. So now we can show to this one here that this is now energy. Here this is n equal to 1. This is now your n equal to 2. This is now n equal to 3. This is now n equal to 4. This is now n equal to 5. So and so on. This can be maintained like this one. This goes up to infinity. So what we have? So this energy state has, this is now your minus 13.6 Z square electron volt, and this is your minus 3.4 Z square electron volt. This is now minus 1.51 Z square electron volt, and this is now 0. With a minus sign, 8.5 Z square electron volt, and this is now your minus 0.544 Z square electron volt. Z square electron volt. This is not so much. So this goes up to so many energy levels. So you can have that at the last. The energy is how much? 0. This is now 0. So for n equal to infinity, n equal to infinity, now this En is equal to 0. So this is now we are having to this infinity, then we are having to this 0. So as the n increases, the excitation energy decreases. So we have that for higher energy levels, the excitation energy decreases rapidly. As you can see that this is now 13.6, this is now 3.4, this is now 1.51, this is now 0.85, this is now 0.544 Z square. So in this way the energy increases very rapidly. So this we have discussed for the hydrogen-like atoms or the ions, and you should remember that hydrogen-like ions or atoms are those which have the one electron in their outermost orbit. So this is suppose this hydrogen, lithium, sodium, these the atoms which are lying in the first group of the periodic table. They are the hydrogen-like atoms. If suppose there is a atom which have the 2 electron or 3 electron in the outermost orbit, if however the 1 electron out of 2 or 2 electron out of 3 are removed, then 1 electron will be there in the outermost orbit. In that case, whatever the spectrum will be given, that will be according to the hydrogen atom. So when there are 2 valence electron, then we have to remove 1 electron. If there are 3 valence electron, then we remove the 2 electron. So the remaining electron will be 1. So in this way, the electron in the outermost orbit will be 1. And in that case, the spectrum given by that atom or the ion, that will be equal to this, the spectrum of the hydrogen atom. So now we are taking only for hydrogen atom. For hydrogen atom. Now this Z equal to 1 as we have. So excitation energy. Excitation energy of first energy level. This will be your minus 13.6 electron volt, and for second energy level, the excitation energy is equal to minus 3.4 electron volt. For third energy level, the excitation energy is equal to with a minus sign. So this is now 1.51 electron volt, and for fourth energy level, the excitation energy this is equal to minus 0. And this is now your 8.5 electron volt, and so on. So now for hydrogen atom we keep the value of Z equal to 1. So if you have here this Z equal to 1, this 13.6, and here this is now minus 3.4, and now this is now minus 1.51, and this is now 0.85, and for next one this will be now 0.544 Z electron volt. So these are the excitation energies of the energy levels of the hydrogen-like atoms or ions and the hydrogen atoms. Thank you very much.